Now we get into the hands-on sessions here. Kicking us off is one of the key contributors to Sysdig. Please welcome to the stage Luca Marturana.
Thanks, Purva. Hi, everyone. I'm Luca Marturana, software engineer at Sysdig, where I work every... The microphone is not working. No. Hi, can you hear me now? Okay, cool. Thanks. I work every day writing system software and troubleshooting it. Let's start from containers. Tons of words I will spend about containers, so I don't talk too much. They are a good abstraction to bundle application and replicate environment and put them in production. All the containers ecosystem is bringing new challenges to us, because when you have container, you have then to orchestrate your deployment. You need to monitor them, to troubleshoot them. There are new challenges about logging, security, many of them. In this session, I'll focus on troubleshooting. Troubleshooting is a bit different with containers. All the tools that we are used to, like TCP dump, Nestat, or LSOF, top, don't play so well with containers. Because, for example, if you think about networking, every container has its own network stack. So if you run TCP dump on your host, you don't see the traffic generated by your containers. You can run TCP dump inside the container, but this means that you need TCP dump inside the container, and it's a bad practice to put troubleshooting tools inside your application containers, because they should be as simple as possible, as lightweight as possible. So all these tools have some glitches that make them not so useful with containers. Sysdig tries to solve this issue, and how Sysdig can do this. Sysdig adds an instrumentation inside the kernel as a kernel module, which is a thin layer that stays in between the system calls that all the applications do to do meaningful stuff. So the application needs to run something that is done by the kernel, and they use system call to do this. Sysdig instrument just is in between and traces all the system calls that are later available to the Sysdig command line utility on user space. So in kernel mode, traces all the events that are then available from the user space utility to do meaningful stuff. Sysdig is able to capture system events, but they are a lot of data, as we said before in the Adam talk. And Sysdig is able to filter them, so you're able to get what you really need, but also run useful scripts on top, which Loris already mentioned. We call them chisels. And with scripts, you can leverage this data to do anything you want. We have also support for trace files, which is a workflow that we've taken from Wireshark. And it's very useful because you can troubleshoot things offline. Like, for example, if you receive an alert from your monitoring solution and you're able to get the chart of some metric going crazy, and a trace file of the system at that time. So even if you were sleeping at that time, you are able to understand what was going on. With this kind of granularity. Sysdig has native support for all the container ecosystem, so starting from Docker, but also supporting Rocket, or all the main orchestration systems like Kubernetes and Mesos. And we released it as open source, is GPL version 2. Sysdig comes in two flavors. We have a command line utility, which is just Sysdig, and a cursus interface, which we call Sysdig. They are, it's the same kind of visibility, but there are different features that makes one useful for certain things and one for another. The Sysdig interface is very easy to use, so it's easy to get into all this data and get something meaningful from them because it's a graphical interface with easy to navigate. The Sysdig command line is more powerful in terms of the thing you can do because, you have a full control of the granularity of data you want to see. You can apply all the chisels that are bundled on Sysdig, but you can also build your own chisels and run them. We will have a session later today about this. And we can also, you can also save trace files that you can use for both Sysdig and Sysdig. Let me show you a demo of about all this thing work. So I have my system here. Let me know if the font is okay. We should have a couple of monitors. So okay, it's okay the font right now. Okay, so when you launch Sysdig, you see something like this, which if you are used to htop, is kind of htop. So the top list of processes running in the system were right now ordered by CPU usage, but you can also order by memory usage, things like that, just with a click of the mouse. So this is the process view, but we have also other interesting views. For example, the container view is much more interesting in a container-based environment because usually in the process view you see tons, for example, of Apache instances. Here you can see there are tons of Apache instances, but from here we don't understand which Apache is running where and what is doing. Instead, with the containers view, we are able to understand what our stack is doing here. We have a MySQL database, some WordPress containers, and Nginx proxy, so we can guess it's a WordPress stack. With Enter, we can go inside a container and see the process view, but of a single container, so there is way less noise inside here. And while we are in a view, we can change it, keeping the same context, and see different data. For example, now we are inside this WordPress container. If we go in another view, like the connections view, we are able to see just the connection of this container. So we are segmenting the data to see what we need. All of this is done without running anything inside the container. So we are seeing this from the outside. We have other kind of activity we can see. For example, this is the errors view, which groups the system calls by the error return. For example, here we see a lot of inoent, which if you're used to low-level programming, it happens when you try to open a file and it's not available. For each row here, we are able also to see all the Sysdig events that are grouped there in this visualization. Just pressing the dig button, we are able to see all the events that generated this inoent error. And for example, here we can see that Apache is trying to open a bunch of files that are not available. But this thing is just how Apache works. All of these features are available also reading a trace file. So reading a trace file, we can see what was running at that time and with all the features that we saw. So for example, I can go again in the containers view. I can dig into a container. I can go to the connections table. And also we have another feature called the echo, which displays the data exchanged. So, for example, here we have a connection. If I press echo here, I can see the HTTP transaction run inside this connection here. So the request and the response. So this is Sysdig, and as you can see, it's pretty simple to get something meaningful for all this fine granularity data we have. Then let's go to the command line. The command line, if you run it just as it is, all the system calls are printed on screen, which is not so meaningful, but the power is on filtering and on running chisel. So, for example, if I filter by container image and I put WordPress, now I see just the events generated by the container image WordPress. And I can also tell Sysdig to write the container context. So here I can see all the WordPress containers that are generating this activity. I can also improve the filter, like add sock family equally p. So now I'm seeing just the network activity. And here we are still on low-level stuff, right? Just the system call. But with Chisel, we can leverage this data to have the data that exactly we need. For example, here there are a lot of HTTP transactions. I don't care exactly about exact system call. For example, I want to see all the requests coming. We have a Chisel that is called HTTP log. And when you run it, you see for every line an HTTP request or with the response code generated with the URL and things like that. And this is done from our Lua script analyzing all this data. So with Sysdig, you can go from low level to high level very easy without having to know deep level stuff like kernel tracing or C++ or things like that.